Hey guys, this is Mrs. Nell, and today we're going to start chapter 11, which is we're going to start with circumference. And you've done circumference before. You have to know pi and the diameter. And so we have here this problem. It's about tire revolutions, and there's two tires from different automobiles. How many revolutions does each tire make while traveling 100 feet? Well, I look at tire A and I see that the wheel itself is 14 inches in diameter. Each tire, or each part of the tire, is 5.1 inches all the way around, okay? And tire B is 15 inches, that's the wheel size, and each tire is 5.25 inches wide. So let's look at tire A first. To find circumference, it's pi times diameter. We know the diameter is 14. We know that it's 5.1 inches on each side, the tire itself. And so when we add those things together and we multiply by pi, we get 75.99 inches. Now, if you rounded pi to 3.14, that's what you got. But if you use the calculator button, you may not have gotten that. You may have gotten a little bit bigger. Same for tire B. All right, so let's look at tire A and B. Well, the question asked how many revolutions. Well, we start out in feet and we need to go to inches. So 100 feet is 1,200 inches. And when we divide 1,200 by 75.99, tire A gets 15.8 revolutions, approximately. Tire B, same thing, and we get 14.99 revolutions. So tire A requires more revolutions. All right, in the last chapter, we talked about the degree of the arc, and we knew that the degree was the same measure as the central angle. But now we're going to talk about the length of the arc, or part of the circumference of the circle. We have two things that it depends on: the measure of the arc and the size of the circle, or the radius. An arc length measures the distance, while the measure of the arc is in degrees. All right, an arc length is a portion of the circumference of the circle. Proportions are determined by how much of the circle it is. For example, 90 degrees out of 360 is a fourth of the circle. 1/4 times 360 is 90 degrees. 180 is half of the circle, because 180 divided by 360 is 1/2, and that's 180 degrees. A third of the circumference, which is 120 degrees, 120 divided by 360 is 1/3, and that gives me 120 degrees. Now, let's look at this last one, 6 pi out of 36 pi. Well, if I put 6 pi over 36 pi, it reduces to 1/6 because the pi's cancel out from numerator to denominator, and it gives me 60 degrees. Let's look at the arc length formula, what we just did. Well, we knew the measure of the central angle. We divided by 360. Well, now if we take that times the circumference of the entire circle, we should get the fraction of the circle. We can use 2 pi r, or we can use pi times diameter. The arc length is equal to the arc measure over 360 times 2 pi r, or pi times diameter, and we know that this has a special name. The special name of this constant of proportionality is called the radian measure of the central angle. Remember, arc length is in linear units, arc measure is in degrees. All right, so now we're going to find arc lengths. We're going to use the formula, the measure of the arc length divided by 360 times 2 pi r. Let's look at A. A has an central angle of 50 degrees and a radius of 5 centimeters. So the arc is 50 degrees, and when I plug and chug, I get that my arc length is 4.36 centimeters. Now B has the same arc measure of 50 degrees, but this time the radius is 7 centimeters, a little bit bigger. That means the circumference is a little bit bigger. And so when I plug it in and chug it out, and I rounded pi to 3.14, I get about 6.11 centimeters. Okay, now see, my degree of my arc is bigger, but my radius is 7 centimeters. So my circumference is the same as it was before, but this time my degree is bigger, and I still am going to get a different number. And this time it's about 12.22 centimeters. All right, so now this problem says we need to find the exact length of arc AB. What does exact mean? Well, exact means that I need a precise answer. Well, when I multiply by 3.14, I get an approximate answer. So I'm going to leave my answer in terms of pi. In other words, I'm leaving pi in my answer. So this first one, the fraction of the circle, is 1/4. 90 degrees is 1/4 times 12 pi is 3 pi units. This one, 240 divided by 360 is 2/3 of 24 pi is 16 pi units. 300 divided by 360 is 5/6 times 24 pi is 20 pi units. The last one, 1/3 times, 2.4 times 2 is 4.8 pi is 1.6 pi units. This last one is not as tricky as what it seems. 108 divided by 360 is 3/10. I double my 10 times the square root of 2. Well, that means I just multiply 10 times 2. So I get 20 times the square root of 2 times pi is equal to 6 times the square root of 2 pi units. All right, so now we know how to find the central angle and the degree from that. We know how to find the arc length. But what if we're given the arc length and the radius? What do we do to find the measure of the arc? Well, we're going to substitute. We're going to put 18 inches in for the arc length, and that's going to equal our measure of our degrees over 360 times 2 times pi times the radius. And when we plug and chug and put everything through using 3.14 as pi, we're going to get that the measure of arc XY is about 135 degrees. Okay, we have one final thing we need to cover, and that is converting between radians to degrees and degrees to radians. You need to remember 180 degrees is equal to pi radians. You also need to remember this conversion tool. The conversion tool is the angle times the numerator, which is what we're converting to always, denominator, what we started with. All right, we're doing 60 degrees to radians. We're starting with degrees and we're moving to radians. So we have 60 degrees times, in the numerator, pi radians over 180 degrees, because degrees is what we're going to. We can cancel out the degrees from numerator to denominator, leaving you with 60 pi radians over 180. Now, I can reduce 60 over 180 to 1/3. When I multiply 1 times pi radians, I get pi over 3 radians. And now I've converted 60 degrees to radians. What about if I'm going from radians to degrees? Well, I have here 5/3 pi radians, and I want to move that to degrees. Okay, so I'm going to this time put degrees in my numerator, and radians in my denominator, when I cancel everything out, I end up getting 5 times 60, which is 300 degrees.